Today we are going to have minimum spanning tree problem. Earlier in the introductory classes we have learned what are the network terminologies, what are the nodes, vertices or edges. Now in the second class we have solved the shortest route or path problem. And the third one is minimum spanning tree problem. Now what does this minimum spanning tree means basically? Look, you already know what does this represents. Okay, this represents arcs, as I earlier told you, arcs. Now it can also be termed as vertices. Okay, vertices. So you can see in this particular network we have got 1, 2, 3, 4, all total of 4 vertices. Now for this particular spanning problem we will call this as vertices. Okay, vertices only, vertices. So tree, we have to make a spanning tree, and one more thing we have to keep in mind, that is it should be minimum. Minimum means you already know these are the weights assigned to the particular path or route. So we have to keep in mind while designing the spanning tree, we have to keep it as low as possible, as minimum as possible. So there are some rules while constructing a spanning tree. Now first you should learn what is a tree and what is the basic difference between the graph and a tree. In the introductory class I already told you that a graph is a closed loop. Okay, it is a closed one, but in case of a tree this can be like this one. It cannot form a loop. If I connect this one, this will become a graph. So we cannot, form a loop in case of tree. Now coming to the, so you have the basic difference, knowledge of basic difference between a graph and a tree. In tree you cannot make a loop, but you have to connect all the vertices. These are the vertices, you have to collect all the vertices. Now coming to the spanning tree, there are some rules. Now look, if you have to construct spanning tree, you have to keep in mind that you have to connect all the 4 vertices over here in the particular network. If it had been a 5 vertices or 6 or 7 or whatever may be the, say, n number of vertices, there are n number of vertices in a particular problem, they are having n number of vertices. Then while constructing a tree you have to connect n number of vertices, but at the same time you have to keep in mind it should not have a loop, right? It should not be closed, as because tree is not closed while graph is closed. Now coming to this particular problem, it has got, see, it has got 4 vertices, but while constructing a particular tree we have got only 4. These are the edges, you can say these are the edges, this one, these are the edges. Okay, so here edges is 1, 2, 3. 3 is the edges. Now from this particular graph you can conclude easily, if we are having 4 vertices, we are having 3 edges to construct a tree. So if you are having n vertices, you are going to have n minus 1 number of edges for constructing the trees. Now coming to the spanning tree for this particular network, you can see for constructing spanning tree with this particular network, we have like this one, say this one, this one, this one, and this one. One, this is the two, let it make it visible for you for better understanding. Say this is 4 and this is 5, this is 3. Okay, now look, I have constructed a tree. This can be named as tree. Why? There is no loop, but I have connected all the vertices. Similarly, you can draw another spanning tree. This one, this one, this one, and this one. Okay, so this one, this is 2, this is 3, and say, or this is 4 and this is 3. So this is another spanning tree. Similarly, you can also construct like 1, 4, 3, 2. Similarly, you can also construct like 1, 4, 2, 3. I have already constructed 1, 2, 4, 3. 1, 2, 4, 3 already. So by looking at this particular figure, you can easily conclude that if we rotate this one, see, if we rotate this one like this way, we will have a 4 number of trees. If you rotate this one, you will have again a 4 number of trees. Now again, I can draw another one for you like this one, this and this one. This is 1, this is 2, and this is 4, say this is 3. Look, I have constructed tree. Why it is a tree? As because I have got connected all the vertices. There is a 4 vertices, but I have not make any loop, not even a single closed loop. If I have had constructed this one, this would be a closed loop, or if I had constructed this one, this would be a closed loop. So you can easily say that these all 3 are the trees of this spanning trees, rather I say, of this particular network. Now earlier I said if you rotate this one, you will get 4 number of combinations. Similarly, if you rotate this one in this direction, you will get 4 number of combinations. Similarly, if you rotate this particular figure in this direction, clockwise or anti-clockwise, you will get a 4 number of combinations. Okay, so 4 number of spanning tree for this particular direction, tree, 4 number for this particular tree, 4 number for this particular tree. Now another one you can also construct like this. 1, it is 4, it is say 3, it is say 2. Look, these are the various spanning trees coming out from this particular network. Again, if you rotate this particular diagram, you will get 4 different spanning trees. Now these are the possible combinations to make spanning tree out of this particular network without making a loop. If you make a loop just like that, if you join this one, it will become a loop, or you join this one, this will become a loop, and this one, it will become a loop. Then it will not be a tree, it will be called as a graph. So this only these 4 possibles you can spanning tree you can draw out of this particular network. So from this particular network we can conclude that 4 plus 4 plus 4 and plus 4, that is 4, 4, 4, 4, 4, that is 16. 16 possible I would say spanning tree. 16 possible spanning tree are coming out from this particular network, but I don't know which one is going to be the smallest one. So for having vertices of 4, we are getting 16 possible spanning trees. This is the first thing you need to know. So now here I have written the summary of this particular spanning tree problem, left side of this particular board. You can have a look over here. Look, the first one says number of vertices. If you are having number of vertices n, then the number of edges to construct a particular spanning tree should be n minus 1. Just like over here, we are having 4 number of vertices, and then we are having edges of n minus 1. That is 3 number of edges. We have already seen in the previous spanning tree I have drawn earlier. Now, number of spanning trees. How to calculate? There is a formula given over here, n to the power n minus 2. That is the formula for number of calculation of spanning tree. Say you are having vertices of say 8 numbers of vertices. Okay. Then number of spanning tree coming out from this 8 number of vertices is given by the formula 8 to the power 8 minus 2, which gives you 8 to the power 6. So 8 to the power 6 possible spanning trees are coming out if you are having a network of 8 vertices. Is it clear? Next, for finding minimum spanning tree, you have to calculate the weights. Weight of MST means minimum spanning tree should be sum of the weight of the edges of MST. Edges means this ones, this ones, this ones, this ones, this ones, this ones. So edges represents the particular weights. Okay. These are the weights. So for this particular network, if you are going to draw a spanning tree, you have to make the minimum. You have to take the minimum number of weights, and you have to make the particular spanning tree. Let us calculate, make the minimum spanning tree for this particular network. Okay. So the first step is to draw the vertices only. So these are the vertices. Okay. Now the next step, we have to connect all the vertices in order to make a tree. I am not saying the spanning tree. I rather say this is only tree. To make a tree, we have to connect all the vertices. But keep in mind, we can't make a loop out of these 4 vertices. Okay. So now coming to the minimum spanning tree. Say this is minimum. We are having minimum spanning tree. For this minimum spanning tree construction, we have to connect in such a way that the weights remain. Weights for this particular you can say the edges remains minimum. So first find the minimum weight from this particular edges of this particular network. Minimum is 10 over here. So we just connect the line for 1 and 2 and write the name, the value of the weight. That is 10. Now see which one is the lowest one. It is 20. So you just connect it 20. This 20 and this is 4. Okay. Now we have got next one is 30. So this will be the 30. Now we cannot, this is 3. We cannot connect this one because it will make a graph, not tree. Now for this particular network, the minimum spanning tree will be 10 plus 20 plus 30, which will be 60. So this is basic, you can say, for constructing a particular spanning tree out of a given network. Now let us take another example for constructing minimum spanning tree. It is a bigger one and it has got, you can calculate easily over here, number of vertices. I would rather write over here number of vertices you can count it 1 2 3 4 5 6 7. So number of vertices is 7. So number of edges from here you can see n minus 1. You can see over here. If number of vertices is n, I have already discussed about this particular formulas in the previous example. So if you are having number of vertices as 7, then number of edges should be 6. Okay, for constructing a spanning tree, not the minimum spanning tree I am going to say, but also if you are going to construct a minimum spanning tree or simply a spanning tree, you are going to have at least 6 number of edges. Now if we come to the combinations, how many combinations are we getting from this particular network? That is a spanning tree. ST means spanning tree. Number of spanning trees is given over by the formula n to the power n minus 2. So it is coming as 7 to the power 7 minus 2, which gives you 7 to the power 5. A big combination of spanning tree. So from this particular network, we are having 7 to the power 5 number of spanning trees. So, but our motto over here is to find the minimum spanning tree out of this particular network. So how to do that? Let us concentrate of finding minimum spanning tree rather than finding 7 to the power 5 number of spanning trees. So I have already told you, to construct spanning tree, first you have to draw the nodes. Only nodes or vertices rather I say. This is the vertices. This is the vertices. This is the vertices, and this one is the vertices, and this one is the vertices. Now you are going to construct the minimum. Keep in mind the minimum. So first we will have to look the minimum number of the weightages given over the lengths, or you can say in the network. Okay. So minimum value is given over as 2. So you can easily connect this one with this one, as this is given as 2. So this represents node B, or you can say vertices B and E. Next, after 2 it comes as 3. But we during constructing, we have to keep in mind that we must not have a loop while constructing the particular tree. So E to F, that is 3. You can construct E to F 3. Now coming to the next, after 3 we have 4. We have 4 values over here. Let us take one by one. Okay, first of all I will select this one. Okay, this gives 4. B and C. Next we have E to G, 4. Next we cannot construct this one. Okay, or if I construct this one, say 4, we cannot construct this one. Either one have to be removed. Okay, either one have to be removed, as because they are making a loop, but it is a tree, so we cannot have a loop. Say I have constructed this one. Okay, and now coming to the next possible entry is the 5. 5 is over here, 5 for D, and also over here this is 5. Okay, now 3 was also here, but we cannot construct 3 over here, as because it will make a loop. Now we have vertices of 1 2 3 4 5 6 7. 7 number of vertices, say V. So number of edges, that is this paths should be 7. This one is a formula n minus 1, that is 6. 6 number of edges we have to construct. How many we have constructed till now? 1 2 3 4 5 6. Okay, so look, we have already constructed, you can see 6 loops. So I think I have made the minimum spanning tree, but I have to check once more. See, if I had been connected, this is the A, and this one is the 3 value over here. If I connect A with C, let us connect A with C and omit this one. So this one is 4 and this one is say 3. Okay, previously we had 5 over here, so that time the total calculation was 5 plus 2 7 plus 4 11, 11 plus 5 16 plus 3 gives you 19 plus 4 gives you 23. Now let us calculate again by going this spanning tree. 3 plus 4 gives you 7, 7 plus 5 gives you 12, 12 plus 2 gives you 14, 14 plus 3 gives you 7, and 14 plus 3 gives you 17, and 17 plus 4 gives you 21 value, which is much lesser than the previous spanning tree. So you can conclude this is the particular minimum spanning tree. Okay, and it has got the value of how much I have calculated? 21. So this is all about the finding the minimum spanning tree or constructing the minimum spanning tree. So I think you have understood how to solve a minimum spanning tree problem. Thank you.